Deep in the universe, there is a spiral galaxy of stars moving through space and time. Far from the center of this galaxy of 100 billion stars, out on one of the spirals, there is a star that is very important to us and all other living things on our planet. This star is our Sun, the center of our solar system. Our home, Earth, is the third planet from this star. There are 9 planets going around the Sun, each in its own path called an orbit. Some planets are close to the Sun, and as a result are far too hot to sustain life as we know it. Some planets are far from the Sun and receive very little energy from the Sun. Their environments are too cold to support life as we know it. But our planet is in an orbit that has just the right amount of warmth for life. What a remarkable collection of life forms there are on our planet. Plants and animals of such variety, big ones, small ones, extinct ones, swimming ones, flying ones, walking ones, running ones, shy ones, fat ones, thin ones, slippery ones, scaly ones, scary ones, cute ones, and all the other kinds of life found on our exciting planet. The energy that keeps everything going on Earth actually comes from our Sun. The sunlight keeps the planet warm and provides green plants with the energy necessary to create food and oxygen. Green plants are the only living things that can produce their own food. They use water and minerals from the ground and carbon dioxide from the air in their food-making process called photosynthesis. The carbon dioxide is a gas exhaled by animals. To animals and humans, carbon dioxide is a waste product, but to plants, it is a necessary part to the production of food. Green plants need those ingredients plus sunlight to change the water, minerals, and carbon dioxide into food and a gas called oxygen, which the plant doesn't need. It just so happens that oxygen is something animals need to survive. So the plant uses something that animals exhale and turns it into food and a gas that animals need. The plant releases the oxygen through small openings on the underside of its leaves. Green plants are the only organisms that produce their own food. Some animals eat plants for nourishment. Some animals eat other animals for food. Some animals eat either plants or animals. But any way you look at it, the plants are the important basis for our entire food chain. And the most important thing to the plants is the sun. Even early civilizations of people living thousands of years ago understood the importance of the sun. Many groups of people worshiped the sun. The Egyptians even had a sun god. Some early people even built structures to help them keep track of important times during the year. Stonehenge in England is an example of such a man-made calendar. The stones were arranged so that at certain times of the year the sun would rise and set at special points or places around this huge stone structure. People needed to know when to plant their crops and when to prepare for the other seasons. People living thousands of years ago were a bit confused about some ideas concerning the sun and the earth. For instance, they believed for a long time that the earth stood still and the sun and all other stars went around it. You can see how they might think that. Does it feel like our planet is turning? Does it feel like the planet is moving? These people saw the sun rise in the east and set in the west, and it appeared that the sun was moving across the sky throughout the day. Now we know that the earth is actually moving all the time. Our planet goes around the sun in a huge orbit. The planet also spins on its axis. This axis is an imaginary line running through the north and south pole of our globe. It takes 24 hours for the Earth to spin around its axis once. We call that a day. One side of the Earth is pointing towards the sun, and the other side of the Earth is pointing away from the sun. During the part of the day we are facing the sun, we are having daylight. During the part of the day we're not in the sunlight, we're having night. So our planet is actually spinning at many thousands of miles per hour to turn all the way around once every 24 hours. Some of the other planets in our solar system spin faster, and some spin much slower. Jupiter, the largest planet, only takes 10 Earth hours to spin around once on its axis. So a day on Jupiter would be 10 hours. Mercury, the closest planet to the Sun, takes 58 Earth days to turn around once on its axis. It only takes Mercury 88 Earth days to go around the Sun once, so the Mercury day is almost as long as its year. The time it takes a planet to go around the Sun once is called a year. It takes the Earth 365 days to orbit the Sun once. So an Earth year is 365 days. To be exact, the Earth really takes 365 1/4 days to orbit the Sun. So every 4 years, we add a day to February to make 29 days instead of the usual 28. This is called a leap year. Probably the most unusual situation is on Venus, the second planet from the Sun. Venus takes 225 Earth days to orbit the Sun, but it spins so slowly on its axis that the Venus day is actually longer than its year. It takes 243 Earth days for Venus to turn once on its axis. Its day is 243 Earth days long. That means that one side of Venus is in sunlight for a very long time, and the other side is in complete darkness. Did you know that we can only see one side of the moon? That's right. The first time humans saw the other side of the moon was when a spacecraft was sent to photograph what has come to be known as the dark side of the moon. Why do you think we always see the same side of the moon? Here's a hint. It has to do with revolution and rotation. Revolution is the time it takes something to go around something else. The Earth's revolution around the Sun is 365 days. Rotation is the time it takes something to spin once on its axis. The Earth's rotation period is 24 hours. So why do we always see the same side of the moon? Here's another hint. The moon orbits the Earth. Well, here's the answer. The moon's rotation is the same as its revolution around the Earth. It takes the moon 27.3 days to rotate once, and this is the same amount of time it takes for the moon to go once around the Earth. So, we always see the same side of the moon. So unlike the popular beliefs of thousands of years ago, the Earth is actually moving very quickly through space as it rotates on its axis, and it revolves around the Sun. Our planet is an average of 93 million miles from the Sun. Sometimes it's a little closer and sometimes a little further away. However, it isn't the distance from the Sun that gives the Earth its seasons. Many places on Earth experience 4 very different seasons. Spring, summer, autumn, and winter all bring temperature and climate changes. In some places on our planet, the seasonal changes are not as dramatic as they are in what is called the mid-latitudes. For instance, for people living in equatorial regions, temperatures and rainfall may vary from season to season, but big temperature changes and snow or ice are uncommon. At the polar regions, temperatures stay cold year-round. The major reason our planet experiences seasons has to do with the fact that the Earth is tilted on its axis. Remember, the axis is an imaginary line that runs through the north and south poles of the planet. The Earth spins around on its axis. Well, our axis is tilted 23.5 degrees. It is always tilted in the same direction. So as it goes around the sun, there are times when the upper half of the Earth is tilted towards the sun, and other times when it is tilted away. This tilt affects the way the rays of sunlight strike the Earth. When the planet is tilted towards the sun, the rays are more vertical, and therefore strike the surface more directly than when tilted away. From the equator to the North Pole is called the Northern Hemisphere, and from the equator to the South Pole is called the Southern Hemisphere. When the North Pole is tilted towards the sun, the Northern Hemisphere is having spring and summer. The South Pole is tilted away, so the angle of the rays is greater, and the Southern Hemisphere will be having autumn and winter. The Southern Hemisphere is always having the opposite of what the Northern Hemisphere is experiencing. When it is spring in America and farmers are getting ready to plant seeds, in South America they're harvesting plants and preparing for winter. When people in America are having summer, people in South America are having winter. As the Earth revolves around the sun, for part of the year the North Pole is tilted towards the sun and the South Pole is tilted away from the sun. For the other half of the year, the South Pole is tilted towards the sun, and the North Pole is tilted away. During these times, some very unusual things are happening at the poles. When the North Pole is tilted towards the sun, it is constantly bathed in the light from the sun. For almost 6 months in a row, the North Pole has 24 hours of sunlight. There is no night. On the opposite side of the planet, the South Pole receives no sunlight, so for 6 months in a row, it is in complete darkness. Then things reverse when the North Pole is tilted away from the sun. So it's the tilt of the Earth that affects our seasons, and not the distance from the sun. In fact, when the Northern Hemisphere is having summer, our planet is farthest from the sun in its orbit. Here's an experiment that can show why the angle of the sun's rays are so important in the amount of energy that reaches a certain area on the Earth. We'll use a flashlight and some graph paper. Pretend that the flashlight is the sun and the graph paper is the Earth's surface. When the sun is overhead and shining straight down, it covers a certain area of the graph paper. Now, to represent the sun shining on the Earth at an angle, we will hold the flashlight at a slant. Notice that the light spreads out over a larger area. When the light spreads out, it is less intense, and the energy also spreads out. More direct light would mean more concentrated energy. The temperatures and climate around the equator don't vary as much as other places on the globe because the rays strike at more of a straight angle. The seasons are very important to the cycles of life on Earth. During spring, the daylight hours begin to increase. Flowers and other plants begin to sprout and blossom in preparation for a new season of growth. During the winter, the plants have been resting, living off of stored food. Now in spring, it will be time to grow once again. Trees will grow new leaves to carry on photosynthesis. Flowers will sprout from seeds and grow stems, leaves, and buds. Even animals that have been hibernating or sleeping during the winter will begin to be active again. While hibernating, the animal's body temperature has been lower so that it uses less energy. This allows it to sleep during the cold winter months and have a better chance of survival. The food its body needs for energy comes from stored fat. Plants and animals can tell it is time to be active again because of the longer daylight hours of sunshine and warmth. During the summer, the world becomes alive with plants and animals. The days are the longest they will be all year. More hours of sunlight means warmer temperatures. Then, as a region moves into autumn, the daylight hours become fewer and fewer. Sensing these changes, animals prepare for the winter. Birds may fly to southern climates. This is called migration. You've probably seen flocks of birds migrating during the fall or spring. During the fall, the birds are flying to southern locations to avoid the winter months. During the spring, the birds return to their northern locations. People have wondered how the birds find their way on what is often a migration of hundreds and even thousands of miles. Scientists believe the birds can tell where to go by watching the position of the sun and horizon. At night, they may even use the stars to help guide them. Some birds may even use the Earth's magnetic field to help tell their way. It's like having a compass inside your head. Birds are not the only animals to migrate. Butterflies and even some whales will migrate during the fall and spring. Squirrels and chipmunks collect food supplies for the winter. Even the trees begin to change. Many kinds of trees lose their leaves during the autumn because they will stop making food during the winter months, the period of rest for trees. As the hours of daylight decrease, the tree begins to stop the flow of water and minerals to the leaves. This causes the leaves to have trouble making new supplies of chlorophyll, the green color that we see in the leaves. The chlorophyll helps the leaf to make the sugar food that it supplies to the trunk and roots of the tree. The chlorophyll begins to fade, and the green disappears. Instead, other colors that were in the leaves can be seen. Oranges and yellows, which were hidden because of the green chlorophyll, are suddenly visible. These are the same pigments, or chemicals, that give bananas, pumpkins, and carrots their pretty colors. Other colors show up as the leaves die. Some pigments are made from extra sugar in the leaves. These new pigments make the leaves turn red, rust, or purple. The bright colors come from leaves that have a lot of stored sugar. As the leaf dies, it becomes detached from the tree branch. A slight wind may be enough to cause the leaf to fall. Soon, all the leaves will have fallen from the tree. The tree is ready for a nice winter rest. These leaves continue to help the tree even after they have died and fallen to the ground. The leaves will rot and turn into soil that can help the tree and other plants grow. When spring comes along and temperatures warm up and daylight hours become longer, the trees will begin a new season of food production as their buds grow into new leaves. The cycle continues once again. Here are some questions about the program you've just watched. Write the answers either on a separate sheet of paper or the supplied viewer's answer sheet. Question 1. What does the term axis mean? Question 2. What is the angle of tilt for the Earth's axis? A. 10 degrees, B. 23.5 degrees, C. 45 degrees, D. 180 degrees. Question 3. How long does it take the Earth to spin, or rotate, once on its axis? Question 4. How long does it take the Earth to orbit or revolve around the Sun once? Question 5. Many places on Earth experience 4 different seasons. What are those seasons? Question 6. Why is the angle of rays of sunlight so important in determining the amount of energy collected by the Earth? Question 7. What does the term migration mean? Question 8. Plants are the only organisms capable of making their own food. That food-making process is called A. Chlorophyll, B. Oxygen, C. Photosynthesis, D. Carbon dioxide. Question 9. Plants produce more than food. One gas that plants release into the air is used by animals. It is called A. Oxygen, B. Carbon dioxide, C. Chlorophyll, D. Photosynthesis. Question 10. What is the average distance of the Earth from the Sun? A. 100 miles. B. 1,000 million miles. C. 93 million miles. D. 365 million miles.